Welcome to another coding tutorial, and in today's video we're going to be making this cool animation using a bunch of arcs. So let's start by looking at an arc function. An arc function takes in a total of 6 arguments, similar to an ellipse function where the first 4 are the x and y coordinates of the center of the arc, and then the third and the fourth are the width and the height, or the diameter of the circle. And then the fifth and the sixth are actually the starting and the ending angle where you want the arc to be. First, I'm going to actually use the translate function to translate the origin point to the middle of the canvas. And I'm doing this so that I can just provide 0, 0 as the first and the second argument of this arc function. And then for the third and the fourth, how about we put in r times 2 and r times 2, and then we're going to declare r, the radius, at 150. And then for the fifth and the sixth argument, how about we start the arc at degree 0 and then end it at 180. And because we're using degrees as arguments, let's change the mode, the angle mode, from radians to degrees using the angle mode function here. All right, let's click run. Now we have an arc that starts from angle 0, and as you can see here, it goes clockwise from the starting point. Let's put in no fill. So if you want an arc that is half a circle like this one, but is the top part of the circle, all we need to do is change from 0 to 180 to 180 to 360. Now what I want to do is that I want to move this arc around the center point, but we can't do it by hard coding these two numbers. What we need to do is that, how about we give an argument called angle and set that angle to 180. We also don't want to hard code the number here at 360. What we want to do is that we want to put in angle, and then we're going to add it by 180, right? Which is between 180 and 360. And then now, click run, still the same, but if we just increment it by, how about 1 degree at a time? And then now the arc is rotating around the center point. Great. Next, what we're going to do is we're going to draw a circle, and this circle is actually going to be at the beginning of the arc here. First, we need to declare 2 more variables, x and y, and we need to use trigonometry to convert from polar coordinates to Cartesian coordinates. We're going to use an equation x equals to r times cosine of angle, and y equals to r times sine of angle. And by doing this, now if we draw an ellipse using x and y as the x and y coordinate, and then how about we do a radius of diameter of 10. Now if we click run, it is at this point, right? But we don't actually want it to be this point. We want it to be at this point. So what we can do is, we can do 2 ways. We can actually just put in angle plus 180 here. Or what we can do, which is the way that I'm going to do it, is I'm going to actually, instead of adding 180 to the ending angle, I'm actually going to subtract 180 to the beginning angle. But now we need to change the starting angle from 180 to, how about we put in 0. And now we get the top half of the circle. And now we can uncomment this out, and then now the arc is moving as expected. Before we move on, I'm actually going to also declare a variable called length and then replace it here. All right, so now we have the exact same thing. Next, what I want to do is that I want to create another arc, the exact same motion, but with a smaller radius. So I'm going to actually copy all of this. Actually, we just need 1 length. So let me just put it up here. Then I'm going to change these to R2 and angle 2, and let's set R2 to be 0. All right, and then the part that we just wrote here, I'm going to comment it as big arc, and then I'm going to just copy and paste this and do another one, and let's call it small arc. and make sure that you put in 2 for all of this. Length is still the same. All right. So you should expect this. Everything is the same. The motion, the speed, everything is the same. It's just that the radius is smaller. But now what I want to do is that I actually want the smaller arc to move at twice the speed of the bigger arc. And what I can do actually is multiplying a variable. Let's call that variable frequency. So this will be f. Let's set that to 1. But then I want f2 to be equals to 2, meaning that for every 1 period or 1 whole revolution of the big arc, I want the smaller arc to rotate at 2 cycles. So what we're going to do is that we're going to multiply all of the angle variables here with the frequency f. So this would be f1, right? So just f. This one will be f. This one will be f. But for the second one, it will be f times f2, angle 2 times f2, angle 2 times f2. All right. So this one is rotating 1 period, but the smaller one is already rotating twice the amount of cycles. So as you can see here, after 2 cycles, it synchronizes, right? After 2 cycles, then it synchronizes back again. So if you change this number to, let's say, 5, it means that the smaller arc is rotating 5 times before this big one rotates 1 time, and it synchronizes back at this frequency here. So that's exactly how we're going to approach it. We're going to have a bunch of arcs with all of these different frequencies or the number of cycles per period. And they're going to synchronize back again based on the number of the biggest frequency. So let's say that we have 5 arcs with frequency from 1 to 5. It will synchronize back after 5 cycles, after the smallest one rotates 5 cycles. Before we start writing an arc class, I want to add one additional feature where I want the arc to do something when it hits a certain point. To do that, I need to show you this one thing. So let me actually comment out the small arc. And what I want to do is I want to print out the angle. So now the angle rotates from 0 to one revolution, which is 360. Then it just keeps moving on, right? But I actually want to cap it at 360. So what we can do is we can use an expression called modulo, which is this percentage sign here, and then put in 360 here. So basically what this expression does is that it returns the remainder between the division of 2 numbers, angle and 360. So with this, the remainder is always going to be between 0 and 359, right? Because when the number is less than 360, it will return that particular angle. But when it is above, or when it is 360 divided by 360 has no remainder, and that will return 0. But then when the angle is greater than 360, then it will return the remainder, which will always range between 0 and 359. All right, so let's see. So now it hits 360, and now it loops back, right? And it will never go beyond 359. Great. The additional feature that I want to do is that when it hits a certain point, let's say we want it to hit this point here where the angle is 0, right? Then it would do something. But if, let's say, the frequency is now 2, and I click run here, when it hits here, it was 180 instead of 360, right? So an additional thing that we need to do is instead of just doing angle mod 360, we need to make sure that we multiply it by f so that the frequency will come into play in evaluating where the circle is as well. So 360 and then 360. So that's how we are going to incorporate angle and frequency into this feature. All right, so let's create a class called arc. Let's come to this arrow here, click the plus sign, click create file. I'm going to call this file arc.js. And then let's go to index.html first to incorporate this JavaScript file. And all you need to do is copy and paste this line of code and then put in the name of your new file. In my case, arc.js. And that's how we integrate a new JavaScript file into the program. All right, let's go to arc.js. We're going to call this class arc. And then inside the constructor function, what we're going to put there is we're going to put the radius, the angle, and the frequency, right? We can put length in there too. All right, so let's start with the radius. So actually, I'm going to set r as a parameter here. Angle, it's going to start all at the same point, which how about we set it at 0. Frequency will be different, right? So we also want that as a parameter. And then length will be the same for all. All right, so we can set it at 180 for now. The next one is how about we do the display method. And what we want in here is this code here, right? To draw the arc. All right, we don't need this. And then make sure that you put in this dot for everything. Perfect. And then the next method is going to be update. And what do we need to update? We need to update two things, right? First is the angle, and then the second one is this additional feature. So let's just copy and paste this part in here. So we're going to increment it by a certain amount. How about I set it as a variable called angle velocity, this dot angle v, and let's set that to 1. And then this part here, actually what I'm going to do is I'm going to write another method. Let's call it collision. And it is basically going to be a conditional statement that says if what? If this, right? If this dot angle times this dot f, the frequency mod 360, is equals to a certain location. So how about we set that as a variable lock, then return true, right? Else return false. And then we want to put in LOC in here. All right, and then now we want to call this collision method, and we can do it in the update method. And to call a method inside a class, we just need to put in this dot and then the name of that particular method. So collision lock. And then what is this point that we want to put? How about we put in 0 for the 0 degree? So this one, it's just checking, right? But what we want to do is we want to put in a conditional statement that says, if this returns true, then how about we change the color of the ellipse? So how about I set this dot C as a new variable. Let's turn it black. Actually, let's turn it red. And then I'm going to also set C originally as black. And then if it does not collide, then let's set this dot C back to black. And then we want to fill this ellipse with this dot C. Okay, so how about we create just one arc first, just to make sure it works. So let's call this variable A, and A is going to be a new arc object, and we need radius. Let's set it at 150, and then frequency, let's just do 1. And then now we just need to call the update and the display method, right? Okay. So when it hits here, it should turn red. You saw that? It's red, but it's very, very fast. Red. Okay, so what we can do is that we can actually give it a little bit of a buffer room so that that red stays a little bit longer. So what we want to do is, how about we create another parameter called buffer. And instead of it returning true or false based on when this actually is equals to the location. We're going to give it a little bit of room. So if this expression is greater or equals to lock minus buffer, so if it's to the left side, and if this is less than or equals to lock plus buffer, and then how about we set buffer as, if we were to do 30, so we give it 30 to the left and 30 to the right. So you saw that it was red for longer, right? So it should be red. All right, so let's say I put in 100. It's red for much longer. So this is to give it a little bit of room between the point that it hits. I'm actually going to set it at 40, and then let's go back and create a bunch of arcs. So let's change this to an array, and how about we set num to be 10, and that is going to be the number of arcs that we're going to create. So let's write a for loop that goes from 0 to num, and then we're going to create a bunch of arcs, new arc objects, right? So instead of 150 and 1 here, let's put in R and F, and we're going to set R as what? So it's going to be based on which number it is, right? So what we want is we want to use this variable I, but we don't want it to start at 0. We don't want the arc to have a radius of 0. So we're going to start with I plus 1 and then multiply it by num. And then if I set frequency to 1 for now, just to see if the radius works. Oh, we need to also call these methods, right? And we can use the same for loop and then call the update, and then the display method. All right, so the radius kind of works, but what I want to do is I actually want to multiply it by R multiple, and this will allow us to set how big and how small the distance between each arc is going to be, because that's going to depend on the number of arcs that you want to create. So how about I set it at 0.5, then let's see. Then now what we can do is also set the starting radius. So let's say I do R0 equals to 30, and then I add R0 here to this expression. Then now the first one is going to be at the radius of 30. Okay, and then for frequency, we don't want it to move at the same pace, right? So we're gonna do the same thing. So I plus 1, then let's try that. And it's moving quite fast, right? So we can also do the same thing by multiplying it to a multiple. Let's call it f mult, and then I'm going to set f mult to, how about 0.3? All right. And now you can change these numbers to whatever you want to get the effect that you would like. All right. And that hurts my eyes a bit. Now comes the final touches. Let's make it pretty. First, what I want to do is I want to actually change the width from 400 to 600. Let's make the canvas a little bit bigger. Then I want to change the color mode from the default RGB to HSB, which stands for hue, saturation, and brightness. And hue is actually the color. It's a range of color on a color wheel where it is expressed by the number between 0 and 360, where both 0 and 360 are the color red. Saturation is the intensity of that color, and brightness is how bright or how dim the color is. So what we're going to do now is we're going to go to the class here. Instead of this .c here, I'm going to set 3 more variables. The first one, h, which I'm going to set as a parameter here. And then s, let's set it at 255, and then b, set it at 255. I believe these are the range from 0 to 255 for saturation and brightness. And then when it collides, I don't want it to change color anymore. I actually just want the stroke weight to be thicker for the arc that collides. And then if it doesn't, then let's move it back to this one. And I want to set the stroke weight based on this variable. And then for fill here, right? And then also for stroke color here, I want to set the color to be at this.h, this.s, and this.b. Then we can copy and paste this into here. And then I'm actually going to comment this out first so that it doesn't move. And then once we go back here, we need to set this new argument for hue, right? So let's set hue to be equals to, how about we divide 360 evenly by the number of arcs and then multiply it by I. And then put in as an argument here. And as you can see here, it ranges from red to red, right? But I actually just want the color that is around here, like this darker blue to pink. So what I can do is I can actually set the starting color, starting hue. So how about I do from 200, and then let's just divide 100 evenly by the number of arcs. And then now we get this range. Perfect. And I also want to change the background color to this color. All right. And now we just need to change a few variables here. So instead of 40 here, I want it to be 80. I want it to be a lot more. And I actually want it to move a lot slower at 0.8. And then we need to uncomment this, right? So that it moves. And let's click run. Oh, and then another thing I want to change is I want to change the size of the circles. Let's do 3 by 3. All right, that looks good. You can change many different parameters, right? And this animation will synchronize this when this smallest arc actually rotates 1 revolution. This piece is a fun piece that combines many different concepts, from how to use an arc function, how to convert from polar coordinates to Cartesian coordinates, and how frequency can impact the movement of this arc. And you can also try to maybe add some sounds to this, and I have other tutorials that does just that, so you can look at those. Give this one a try.